This is a video going over some of the problems on 1.4. And first for 3, when we're A and B, when we're thinking about adding functions, the question, or subtracting functions, do we still have a function? Are we still retaining that property that a single input will result in a single output? And yes, the answer is because if a of x is a function, we know that will result in one output. And if I add that to another function, which results in only one output, then adding those two numbers can only be one answer or one output. The same goes for subtracting. So for number 4, in order to find h of 6, I need to find a and b. So this is just a simple systems of equations. So you're given that when I input 1 to the function h of x, the output is 5. Okay, so let's see what that tells us. So if h of 1 then is going to equal, it means wherever there's an x in my function, I'm putting a 1. So it'll be a times 1, which we'll just write as a, plus b. And I know that output's 5 based on this statement right here. Let's do for -1. If I input -1 in for x into my function, I'm going to get -a plus b in this case. And that I know based on this statement here equals 1. Now this systems of equations is pretty straightforward. I'm just going to add these two functions as is, or these two equations as is, because the a's are going to cancel if I add it. So I get 2b equals 6 and b equals 3. And so let's just plug b into one of the equations. So a plus 3 equals 5. So a is 2. So that means that my function here, h of x, is equal to 2x plus 3. So if I want to find h of 6, now that I have my exact function, I'm just going to plug in 6 for x. And my function will be 12 plus 3. My output of that, when I input 6, will be 15. Okay, so now let's look at next page here, because this one, particularly C, can be a little bit tricky. Okay, so we have two separate functions, root x, and remember the square root function is in function, and when you see that square root, there's not going to be a negative coming out of it. It just means what is that square root symbol means what is the positive square root of some input. Okay, so the domain of f of x, I'm going to write the little f so to differentiate it from g. The domain of that function, remember, you can only input positives into a square root, so it's going to be 0 to infinity. And the domain of g of x, well, I need x minus 6 to be greater than or equal to 0, so the domain has to be 6 or greater, so 6 to infinity. Okay, so what about a new function that is s of x, which is formed by combining f of x plus g of x. So that function would be the following. S of x would equal f of x, which is root x, plus root x minus 6. Okay, so it indeed is still a function, as we discussed in the previous page. In this case, the domain, remember, it has to meet both these square roots because this is a single function. If I just said 0 to infinity, problem here. So you're going to take the most restrictive in this case, which would be because it has to, again, meet both square roots. So the domain is of s is going to be 6 to infinity. Well, that's actually going to change the range here, or affect the range, because again, the smallest I can put in is 6. So if I do that, if I do s of 6 here, I'd get root 6 plus 0. And then if I put in anything greater, I'm going to get a greater output. So my range of s is, in fact, with a bracket, root 6 to infinity. Okay, so now on to C. It's saying if I divide these two, is it a function? Yes, it is. The domain is, so here's what it looks like. D of x, maybe I'll do a different color here. So D of x is going to equal root x over root x minus 6. So very similar domain to B, except I can't divide by 0. So my domain is not going to be 6 with a bracket to infinity. Instead, it's going to be 6 with a parentheses to infinity. Okay, so for part 3, for what x value will d of x equal 0? So let's see, root x over root x minus 6 equals 0. Well, if I were to try to solve this by multiplying both sides by root x minus 6, I get this, and then square both sides, I get 0, but 0 isn't in the domain of the function. So there's never going to be a value here. What about equaling 1? Well, root x over root x minus 6, will this ever equal 1? In other words, will root x ever equal root x minus 6? And the answer, if you can't already see it, you could square both sides and see that, will it ever be the case that can I solve x equals x minus 6? And the answer is no, because the x's would cancel and you'd be left with a false statement. So this too is never. Now the range is what is tricky here. Well, not that the other parts weren't tricky either, but the range. So we kind of have similar to what we had before. We have root x over root x minus 6, and we know it can't equal 1, and it can never be 0. I also know it can never be negative, right? Because coming out of a square root can only be positive, so I've got a positive over a positive. So the question is, I'm really looking at this. So I know it can't be 0. I know it can't be 1. So the question is it all of this here or not? And you actually can kind of, if you look at this, you can reason it out. Because I have the square root of x over the square root of that same value minus 6, the denominator is always going to be a bit less than the numerator. So it'll never get to the point where it's getting super close to 0. In which case, we're going to be left with this right here. So the range here is going to be 1 to infinity. And if you wanted to further kind of figure that out or reason it out doing what we did with the k thing, you could do that. So let's look at that. So say I wanted to set it equal to some value k. Then I'd multiply both sides, so I'd get by root x minus 6, so I'd get root x equals k root x minus 6. In order to deal with this, I'm going to square both sides. So I've got x equals k squared times x minus 6, or x equals xk squared minus 6k squared. And like we did before when we had a linear equation, the only thing you can't have k squared in this case be is 1, because then the x's would go away. So you're going to say k squared can't be 1, which means k can't be plus or minus 1. We already know it can't be negative anyway. So in essence, that would give us this, where we are here. But then we reasoned out that it can't be 0 to 1 either. Okay, that's a hard problem.